Hello there. I don't know if the audio levels on this are good or if anyone's watching yet, but I'm going to attempt to do a little bit of a live stream from the lab. We'll see how it goes. Today, the big order of populated circuit boards arrived a little ahead of schedule. I was originally hoping that it would arrive on Friday. And tomorrow, the 3D printed enclosures for the densitometer should be arriving. I don't expect to get that much work done this week, but with any luck, next week is when I finally kick this into high gear. Also, the calibration references that I'll be including with the device also arrived this week. But going through and measuring and labeling all of those is something I'll probably do on the tail end because I don't actually need them until the completed devices are ready to ship. So I'm going to be basically putzing around here in the lab, talking at the cameras occasionally. I still haven't quite figured out the best arrangement of cameras that works well here. I've got a few going. The one I'm speaking to right now is a fancy webcam. I also have my normal video camera I use to shoot all my other videos. That'll be moving around a little. And I also have a microscope camera. I don't like using it that much because right now its focus point is a little different from the eyepiece, and I really like using my stereo microscope as a stereo microscope, and using that camera means I have to blind one eye. So I might switch over to that periodically, and of course desktop sharing whenever is necessary. Looks like someone's jumped in. Good, the audio is good. Let's see what we've got. So here is, you can see over behind me, there's the bench. Actually, that's not the main bench. That's the wood shop, or workshop bench. Here, let me get up and pan around a bit. So this is the bench where I just use as a general workspace. Over here is the main electronics workbench where I do all my electronics stuff. Yeah, so over here are all the bags of parts that have arrived. And the webcam's yeah, even in the background of the main camera. So got a bunch of things going on here. Yeah, so all the parts stuff came back. In this bin I've got components I'm going to have to inventory. I have no idea when I'm going to get around to it, but I will need to eventually. Cut tape, component reels, and then some unpopulated circuit boards. It's going to be a little annoying to go through. If any boards need rework, I'm going to have to go into these parts. I also have all the circuit boards that I did a checkout of last week. It's a tedious process that's going to get better. I don't know how much I'm going to do today. It's probably easier to do when someone's not looking over my shoulder. But yeah, I basically have a month to get through the full stack of circuit boards just so that I can send off my tally and let them know if anything needed fixing and what to get refunded for. But yeah, I mean, my general production plan is really to go ahead and take a limited initial batch of devices, completely build them, go through the entire process to finish packaging, and then actually get them for sale on the store page. And once they start going out, I can move on to building the rest of them. In fact, might as well show you what that's going to look like. So I haven't made this completely live yet, but at this point it's more laziness than anything else. So we'll just take a moment. It's also been a really day. My car has been in the shop for about a month. I just picked it up not long ago. It needed some parts. There was some long lead time. It's annoying. Come on. switch over to desktop share. Yeah, okay. Actually, wait. No, this is what I wanted to. Okay, this is the way I wanted to show it. Okay, so this is actually what I expect to be the main product page. So if any of you have been to the Dektronics website before, you've seen a page that looks very similar to this. In fact, the store page is really just kind of a copy of the current more info page. But when I'm actually going to sell it, I need something that looks like a store. So yeah, I mean, I've been waffling on price, but here you see what it's going to be. The Printalyzer densitometer is going to be, I'm planning on actually having it with an official price of $2.99, and at least at first I'll be selling it for $2.49. You can call that an introductory price or a sale price, or a price to get the ball rolling. I've always been contemplating selling it somewhere in this range for a while, so I just had to go ahead and deal with it. I'm also gonna, for now, tell everybody availability expected late October. I don't know when availability will really be. You know, if I wanted to be super optimistic, I'd say the end of this month, but you know, I have kids in school and there's various holidays and various breaks and something comes up all the time. You know, getting a full day of work a full week of work in, you know, every week between now and then is impossible. So this is hopefully when I should have some units ready, but you know, no promises. And some pictures of preliminary packaging. Oh yeah, I played around with shrink wrap a little bit. We'll see how that goes. List of everything that's included, and then just some videos about it. Almost everything on this page is on the existing more information page. Ah, okay. Certain Exposures is asking where's the music. I don't know. I never thought about having background music for a live stream. I mean, I like always having music playing when I'm actually working on stuff, but then I'd be worried about a copyright strike or something. If you have any recommendations, feel free to let me know. Either how to get it going or what kind of music you think would actually work well for that. So, yeah. But let's get over to what we're at. So over here, this is a piece of software I've been playing around with a bit. It's called Base Row. It's something called a no-code database. Just teasing. Okay. The idea is I've always been looking for something that provided this combination of a spreadsheet and a database, because you know, I want to track lots of information about everything I'm doing, every device I make, all of its properties, calibration, notes, you name it. And I want to be able to link the data together a little better. And so I stumbled across this thing called Base Row. It says it's an Airtable alternative. That doesn't mean anything if you haven't used either. But it's kind of like this spreadsheet database hybrid. I really like what it's trying to do. I really don't like how it's simplified both the spreadsheet half and the database half to the point where I find myself screaming at it. Like, you know, I wish it was more friendly to mucking around on a keyboard or expanding things, or, you know, formulas are a bit easier or relations are a bit easier. But, you know, it gets the job done, so I've been trying to make it work. So as you can sort of see over here, you know, I've got a couple of different tables. This is one I made for circuit board checkout. Each panel, which is this thing that contains about 6 circuit boards on it, I check them out one at a time. I I go through here, the date it was received, the circuit board serial numbers that are on it, any ones I had to fix, whether I've taken it apart, basic details. Then for each circuit board, I've got this gigantic table where I'm tracking everything I've checked, all serial numbers. There's a whole list of inspections and checkouts and notes. And then when I get over to final devices, I've got a different list. I could link them, I haven't at the moment. So, part number, hardware revision, date I put it together, what references came in the box, any notes I have on it, similar things for calibration strips that are going to go along with customer devices. So, yeah. Probably going to be mostly putzing around here. I know I've been talking quite a bit. But okay, so, yeah, so over here are all the component bags. I'm figuring I might as well start numbering some things today. I don't know if I'm really going to start doing PCB inspection. So all the panels I've received so far, I've numbered 1 through 9, so this should be the rest. So, let's see. I'm going to number them, probably going to number the outer bags. So these are partial. Yeah, each of these has, says 30 articles. Obviously, 30 divided by 6 is something I should be able to do in my head, but that means there should be 5 panels in each of these. I'm just going to label them so I don't have to think about it. With the earlier ones, it was, I kind of wish I could number these panels in the order that they actually assembled them, but that's a bit harder to do because I don't know, but they sent me an initial batch of I think 8 panels to get me started, and for that, it was pretty obvious which ones were done first because they had more issues and more signs of rework. But obviously I didn't know how to number them that way, so the numbers are a little scattered. Certain Exposures is asking if I started thinking about my next product. Yes, I actually have. So one of these days I'm going to have to get back to the Printalizer enlarging timer and exposure meter. People always want that. The problem is it has a lot of components that you can't get right now, and it still needs a fair bit of engineering work. I need to pick a new light sensor for it. I need to rethink some things with how it controls the enlarger, both for future proofing and certification. It touches mains electricity. I don't want to get sued if someone burns their house down and decides to blame me. So that's complicated. The thing that I really want to work on next is actually a color version of this densitometer. The average hobbyist might have less of a need for it, but anyone who wants to do process control with developing color film absolutely needs it, which would be labs and maybe some more advanced hobbyists, and also anyone working with alternative processes. In fact, once I get this project underway and stop, distracting myself from it, I really want to go heads down into some R&D work for a color densitometer. The real trick with that is I need to pick a sensor and figure out if I can run the calculations on its output to get the data that I want. The whole key to this project is being able to use affordable off-the-shelf components in interesting ways to get what I want done. If you ever look at the way the fancy X-Rite color densitometers work, that would be way too expensive for me to do. They actually have this sensor head with this ring of photodiodes with individual filters. Yeah, that's just not gonna fly. And I've done a lot of experimentation with different sensors. At one point, I even built this gadget right here, which takes a development board from the company that makes these sensors, and actually has some LEDs around it. I've used things like this, but there's really two sensors that I'm trying to decide between. One of them is pretty much a drop-in for what I'm using right now. There are some electrical differences, but I could make something that was physically identical and it would work. The problem is it might be a little harder for me to get good standards compliant data out of it. The other sensor I've been thinking about, and I've got a development board for it right here. If I can get this thing open. Can I get this thing open? Okay, it's proving a little annoying, but let's see. I can pull up a picture. So, yeah, here we go. So this is exactly the circuit board that's inside this thing. This is sort of the fanciest spectral sensor AMS makes. It has these three fancy sensors in a ring. This could work real well, but it's mechanically more complicated. The problem with building a color densitometer is you need to basically measure light transmission and reflection at certain very specific wavelengths with a very specific distribution. And whether you're doing a status A or a status M, which has to do with positive or negative materials, that's shifted a little bit. And it's, can I build a rough color densitometer easily? Can I build one that actually gets close to the standard? That's the challenge. And so if I built something with this sort of sensor chipset, it'd be a little harder mechanically. I might have to change the design of the head. My goal is to build something that's as close to the current black and white model as possible so I can share mechanical components. But yeah, there's going to be a lot of R&D on the sensor. So yeah, the goal is to build a color densitometer next, or at least try. It'll take some research to do. Did I ramble too much on that? So, I'm going to designate these bags over here just based on what I'm going to number the panels inside of them. But, oh, yeah, also I've got two more. This says 18 articles, which would be 6, 12, 18 articles, 6 per panel. Is that going to be a half panel? No, that's, sorry, my math's bad. That's 3 panels. So this is going to be 3 panels. and then this last one is going to be 2 panels. If you want to know what a panel of this looks like, I've probably posted some stuff to Twitter or Instagram in the past. But yeah, so let's figure out what number we're going to number all these, just so I have an order to go in. If I'm lucky, there won't be a difference between these as far as build quality, and they'll all be equivalent. So yeah, so I've done 1 through 9 so far. So we're just going to call this panels 10, 11, 12, 13, 14. Yeah, 10, 11, 12, 13, 10 to 14. 15, 16, 17, 18, 19. I'll number the boards later. Okay, 30 to 34. 35, 36, 35, 36, 37. 38 to 39. Okay. That's a total of 39 panels when I'm done. So each panel contains 6 circuit boards, generally. Oh yeah. Just for kicks, let me just show you what the microscope camera looks like. This board is not that interesting. It's just a kludge from tinkering around. This sort of shows what it looks like under the microscope. I've got these boards go on the bottom of the device. They hold the LED I use for transmission measurements. There's a connector on one side and an LED on the other. This is actually not the LED that I'm using. It's one that I'm considering for the color densitometer. It was just easier to solder it onto this board for some tinkering. And I'm back to nobody watching again. Oh well. Okay, so. These bags look like they're all custom heat sealed. Kind of wish I had the equipment to make these myself. Probably just stick these into Ziploc bags when I'm done. So I'm gonna run off and let's see. Yeah, I'm gonna run off and I'll be right back. I'm just gonna go get another bin. Okay, got a lot of these laying around. Nice little semi-sealed bins, good for storage. Not sure how many of these boards will actually fit in there in their current state. I don't really want to put any pressure on them. I want to have at least one of these packages out. Oh, right there. Yeah. 10 to 14, 15 to 19, 20 to 24. Okay, so yeah, the goal with, I'm wondering if I should attempt to take out one circuit board and go through the checkout, or one circuit panel and go through the checkout process. The general goal at this point with initial checkout is twofold. First, actually I don't know if it's twofold. The main purpose, yeah, twofold, is first see what works, and if anything needs fixing and it's simple, fix it right away. If it's complicated, save it for later. Complicated has traditionally meant something like a part is missing, or it takes me more than a few minutes to fix. Usually the part is missing. Again, this happened a little bit with the earlier boards. It hasn't happened as much lately. But yeah, we can start with this process. So let's see about moving the camera over. See if I can show you the bench. Probably need another camera to make this really work well. Okay. So there's the bench. Turn on some test equipment. So, probably not going to go too deep into this today. This is obviously a lot easier to do when I'm heads down on it, blasting music, not trying to talk to anybody else. But I can go through one. Okay, so we'll take our first panel out. Just to show you what I've got going here, above the bench there's my multimeter and power supply. Yeah. This will take a bit of figuring out on the bench. Yeah, I wonder if I should keep this camera here when I talk to everyone. Maybe make it a little smaller. So, yeah. Another thing I've got back in here, you can probably see, I made this little guide to help me remember which board is which, because I only number them on one side. I still flip it over 100 times because I keep forgetting and mismatching orientations. My goal at this point has been to label these panels as extensively as possible to deal with that. So anti-static wrist strap. So first step to doing any of this is really labeling. So this is panels 10 to 14. So we're going to first take the panel out of the bag, and we're going to label the bag panel 10. And going to decide what we're going to do here. So this is going to be panel number 10. The date is probably going to be based on when these panels shipped to me. Let me just double check that on my phone. September 12th. So we're going to say these were all made on September 12th. I know they were made a little bit earlier than that, but that's when they shipped. Actually, wait, no. I was told that they were ready on Friday, but they missed the cutoff. Let's just call them September 9th. The starting for this is going to be board number 66. Okay, go over to PCB checkout. So we're going to number 6 of them, so it's going to be 66, 67, 68, 69, 70, 71, and this is going to be panel 10. Auto-populate the date over. Okay, so next thing we do is, so I said that this was going to be 66 to 71. Yeah, so I'll just number that on here. Put the bag aside. Okay, so this is the circuit board. Maybe I can zoom the camera in a little more on the bench to the relevant area. Okay, so I number this, so according to my guide from the component side, this should be 1, 2, 3, 4, 5, 6. So if this is 1 on this board is 66. So we'll put a mark on here. There. The hat's just to keep the hair out of my face, really. So this is 66. We'll flip this around. We'll number these. There's a spot here to put serial numbers. So 66, 67, 68. So 66, 67, 68. This should be 69. And this is panel 10. Now, when I'm actually ready to go ahead and depanelize these things, mount the displays on, and do everything else, I've got these little notchy depaneler tools to use for that. But right now I'm trying to keep the panels together for organizational purposes. So the next thing that we need to do is, just a sec. Yeah, the next thing is I need to start with the inspections. So the first step of the process, which I've kind of laid out, is I need to do a visual inspection of each board, and then note any issues that I find. So I tend to be relatively nitpicky, so if I wind up stopping frequently, don't worry. If I want to show you anything, maybe I'll flip on the microscope camera, but as I said, I much prefer using this. This is technically a trinocular microscope, but it's really a stereo microscope with 3 ports. So I very much like using it as stereo. It's much easier under the eyepieces that way. So we're going to start with 66. Let me adjust this, see what we can do. So let's wonder if I can zoom in a little closer. Don't mind me if I end up knocking around a bit. Apologize if you see the back of my head a little too much. Okay. So, also, I know it's been a point of interesting controversy. I know even Dave Jones has done a video on it, but this is a polarized light. It really helps with reflections and seeing printing on chips. If you buy these from all the domestic electronics places in the US, they want like $400 for this or something. I found the identical thing on AliExpress for like $100 plus shipping. So I'm gonna look over this first board. Obviously, if I wasn't talking, I'd do this a lot faster. And maybe I'll flip over the microscope camera and show you what I'm looking at. Okay, for the most part, the first board looks good, but let's turn on the microscope camera just so you can kind of see what we're talking about. Might take a little bit of effort to make all this fit in properly. So one annoying thing about this microscope camera is its focus point is like different from the eyepiece, which is very annoying. Maybe I'll fix that someday. I've ordered additional adapters. But yeah, so this is what the circuit board actually looks like when you go in close. And so, you know, what am I looking for? Well, like, take this switch here. This switch detects when the densitometer is open or closed. Look at how big my finger is. Should probably, yeah, use this. So it's a switch. If it clicks, I do test it. Actually, doesn't make a clicking sound, but it works. So I'm checking, you know, is it in right? A lot of the time, they seem to have gone in a little rotated. But as long as the plunger is dead center, that doesn't really matter. The camera this way is making it look like it's got a tilt to it. I assure you it does not. It looks just fine. So, looking at other various components. If you remember, I was mentioning about polarization. I'll get to that in a minute, but like, there's the microcontroller. You can see that there. Just checking all the solder joints, making sure no parts are missing. One thing I've been nitpicking a lot about, though I think I don't have to care as much as I used to. Let me zoom in. Let's see, is these things right here. This thing here, right dead center of the microscope view, that's what's called a TVS diode, or transient voltage suppression diode. The idea for this is if you run around on a carpet and then touch a piece of metal on the device, that will short your shock straight to ground and not fry the electronics. The ones that I wound up picking are extremely small and very hard to get them placed correctly. If I do another revision of this board, I'm definitely going to pick larger ones. Not all of them soldered in perfectly, so I'm checking these. Thankfully, when we did EMC testing of the board, we had this big zapper gun, and pretty much nothing besides the USB connector at the back actually arced, and that uses a different TVS chip. So I'm not really worried about these doing anything. In fact, I almost want to say they're more just paranoia or CYA at this point. So I've kind of decided to stop nitpicking them too closely. But, talking about the whole polarization issue, back, before I had any kind of polarization on my microscope light, they look like that under the microscope. Well, they're diodes. You have to put them in the right way or they don't work. So how do you know which way is the right way? Well, you have to look for the stripe. You can't see the stripe. So you have to tilt them at an angle, squint at them funny, or use a polarized light, and that helps a lot. Or what you can also do is you can have, instead of using a ring light, you can have the lights be off to the side at an angle. That would probably help too, but that's a little less convenient. So a few other things I'd just like to show that I like to look at on here. Let me zoom out a little bit. So also like to make sure that all the pins on the USB connector are soldered correctly. The pins on the display connector over here are all right. And of course, most importantly, is this right here, which is the light sensor. If this doesn't work, we don't have anything. So the sensor is almost always soldered correctly. It's these two components next to it that sometimes have had shoddy soldering on some earlier boards, but these look fine. So, let's turn the microscope camera off, and I'll go ahead and get back to actually inspecting these things a lot more quickly. So, I'll maybe turn it back on if I spot anything worth talking about. But yeah, stereo microscopes are really nice to use for this kind of work. I would not recommend anything else. Don't bother with those USB, it's on a stand with a screen on top of the things. No, you want stereo because you want depth perception when you're looking at things this tiny. And yeah, the view to my eyes looks so much nicer than what that camera shows you. So, yeah, the first board's good. Okay, that was 68, 66. Just check that off. '67 is the next one down. decently okay. Sometimes even the, it's amazing how disgusting some circuit boards can look if you zoom in close enough. But you're never going to notice that with a microscope. I'm just going to take a note, actually. So the first board is. Yeah, thankfully, the more I get into this batch, the better the average quality seems to be. Yeah, speaking of like TVS diode issues, I might complain about or might not. Here. Every once in a while I'll see something like this, where it looks like it's a little bit off the pad. Again, as I said, in testing we use this big fancy spark gun and none of the buttons arced, so I'm not really worried about this even being a problem. The only reason I even put these on here in the first place is just out of an abundance of caution. But, sometimes I'll do a little test. And, I'm not sure if the contact is completely good. It's not always clear, how the diode tests will read, but. Oh, right, wait. Forgetting. Diode tests, I can use these backwards. So that's reading the volt drop. It's often hard to tell. The data sheets say the drop should be a volt under certain conditions, but these conditions may be closer to 0.7. Some of these read 1, some read 0.7, but they'll sometimes read that even if they're missing completely. So, it's just sort of a quick check, but I've given up caring about these too much. I'm just going to take a note. That was 68. Again, not really a concern. The only piece of metal that's even exposed from this thing that you could get a finger anywhere near is the little detect button switch at the back, and even that's kind of hard, and then the USB connector, which has a completely different kind of protection, which doesn't get fussy. It's not difficult to solder. So, let's see. But yeah, the further we get into the production run, some of the early boards were horrible and had lots of signs of being fixed up. But most of these all look pretty good. That's what I'm going to have to revisit. Okay, so where's our one supposed to be? It's really sharp multimeter probes. They're actually not so sharp under the microscope. Should be a 22 on resistor. Let's try this on this board just. I wonder if I can just do it from here. Yeah, that works. Okay. Okay, here's an example of something that I might leave as a to-fix later. I mean, probably not this minute, but so this is 69. Say. Okay. Okay. So, here we go. So the thing in the middle right there is the light sensor, but if you look over here, this resistor and this capacitor help provide power to it. And if we go in a little farther, don't know how easy it is to even see this here. To be honest, it's very hard to see on this camera. It's easier to see just visually. This resistor, one of these sides of it might not be soldered perfectly correctly. If that's not, the light sensor actually won't even power up, which should be obvious once we start doing checkout testing. It's pretty easy to fix. I just took a note of it to revisit later. So maybe I should get a proper trinocular microscope where I can actually have everything going at the same time. I've run into that before on some other boards. Yeah, you know, it's easy to miss that. It perfectly fine, and then, you know, you load the test code on it, and oh no, the sensor doesn't start up. Of course, even things that should be obvious on the visual inspection I've missed before. Also, for some strange reason, these LEDs don't always get soldered correctly. You can't see it visually, but once I plug it in, you'll know if one of them doesn't work. Oh, and this one, R1 looks a little off too. My clicking and clacking. Okay. So I've got the last board. Hopefully I'll go through this a lot faster once I, you know, get into the groove, maybe tomorrow. Yeah, the rest of that looks fine. Okay. Visual inspection is finally done. I'm not going to do any rework yet. The next thing we do is what I call the smoke test. The smoke test is when I actually start getting a multimeter, testing the power rails, making sure there's no shorts, and then eventually give the thing power and make sure nothing is looking weird. I should see if there's a good way that I can make it obvious what I'm doing with that. We can obviously see the boards. The multimeter might be a bit harder to, the test equipment might be a bit harder to see. Actually, I wonder if I can move this webcam to point at it. Oh, yeah, sort of. Ideally, I would just have them like overlaid from a web browser or something, but one of them seems to want a password that I don't know. Okay, well, see if I can pull up anything over here. So multimeter and supply. Power supply is the one that seems to want me to log in. Yeah, probably no point in showing this off anyways if I can't make it. Kind of wish I could zoom in better on these, but I really can't. So first what we do is we go into continuity mode. We just go board by board, make sure there are no shorts. Right touch line has to be ground, you're going to see a beep. Otherwise, we just bump the power rails going through very quickly. Honestly, there's very little on here that could actually short, so this test might almost be a waste of time. I mean, the only place, unless there's something horribly wrong with the circuit board manufacturer itself, the only place ground and power might even be near each other, like at the USB connector, and even then that's questionable. Okay, so next thing we do is we check the power rails. I have a power supply set to output 5 volts with a current limit. We'll go board by board. What we're making sure is, so I'm going to be looking up here, making sure that this has the right current. If no firmware is running on it at all, the board should be drawing like half a milliamp. Actually, it's 0.4 milliamps approximately, give or take. And then over here, which you'll be able to see, only measuring the power rails, 3.3 volts and 5 volts. So here we go. That looks good. Oh, right. You can come with a better way of getting your instruments on the screen. Those are all perfectly fine. What? Wait a minute. So. Okay, that one's weird. 69 is acting up. Okay, 69 is a fail. Let's just check the rest. That looks good. Okay, everything except board 69 passed. Let me go ahead and just mark those on the smoke test. Now, we've got to figure out what's wrong with board 69. I'm going to guess it's something I completely missed during the visual inspection. So we're going to bring the microscope out. So just to let you know what I was seeing, if we plug any other normal board in, as I was saying, this right here should be showing about 0.4 milliamps. But on this one, it's like limiting. It's acting almost as if there is a short, which is weird because I did the initial testing and I didn't see a short. So I'm gonna have to check this one again. Seeing continuity. So yeah, continuity. Nothing at 3.3. Wait. Yeah, sometimes it shows power across, sometimes it doesn't. 5 volts. Okay, now it's actually, yeah, it's showing some resistance. What could I have missed? Well, probably the easiest way of doing this is keep the power supply turned off. So we stick this should be ground. It's perfectly fine. So power. Yeah, this is kind of a shortcut. Let's look very closely. So the USB connector. Visually looks good. And it goes into this fuse. Frequency volt regulator here. where else could there even be a short? The display connector is always a possibility. Under the sensor, maybe? I don't know. There's really nothing obvious. Actually, I can probably isolate the rails. So let's see. Maybe we should just first see if there's anything between 3.3 and ground. Measuring 1K. Let's see, measure across. Actually, nothing, right? I think it's probably better if I don't waste anyone's time and we just set this one as a checkout fail and I revisit it on my own time. So let's just say possible power rail short needs debugging. Okay, so we might as well move on with the process for now. We'll test all the boards that are not questionable, just because it's easier that way. Yeah, so the way we do that is we use test firmware. So test firmware works out pretty well. Let me get that going over here just a sec. Come on. Yeah, we'll do a quick run with the test firmware and then I'll call it a wrap. Let me see what I can do. Desktop, yeah, so we need the programmer. Okay. Okay, so here's how this process works. What I'm going to do is I'm going to connect to each board. We'll skip 69, so we're going to start with 66. I'm going to connect to each board right down here. We have this programmer. They're called tag connect connectors. Means I don't need a special plug. We connect the programmer, we connect the power, and then what we do is we load firmware, and then on the desktop you should see some output, and we'll take note of device serial numbers and do some testing. So yeah, gonna connect. Oh, what? Oh, right. Okay, And once the test firmware is loaded, the current draw should jump to around 20 milliamps, but you can't really see that. Wait a minute. There we go. Okay. Do automatic mode. That'll make it faster. Okay. Okay. It says it verified successfully, but it didn't reset the device. That sometimes happens with this tool. Just stop automatic mode. Okay, so this is what we see when we want to check out a device. When it first starts up with the test firmware, we get this dump. This is the microcontroller serial number right here, which we want to paste into our grid of checkout info. And then this tells us that the light sensor initialized correctly, which is what we want to see. Then we go through and we press all the buttons, make sure that they register. They'll print a message on both down and up, so every time I press it, you'll actually see it twice. This one will also read out the microcontroller's measurement of its power supply voltage, temperature, and it'll do a read off the sensor, which is another way of knowing everything's working. And there's the detect switch. The only things we don't test this way, the screen, unless I connect them, and it's kind of annoying, and the transmission LED board, but it's very rare that those will have any problems. And it's hard to connect those and disconnect those in this bench setting. So I'm not worrying about that for now. Okay, and then we go on the other side. We look at the board, make sure all 4 lights are lighting up. And we move on to the next one. So that was a pass. There we go. Let's try this again. Okay, next one initialized just fine. Do our little button routine. Everything looks good. Okay. Power off. Move to the next one. Automatic programming mode worked there fine. I think what happens is this run after programming button, I have to like manually toggle every time. I don't know what's up with that. Okay, so this one loaded up fine. So as you may have noticed, each microcontroller has a built-in serial number. This is one way that I can track the devices besides reading the serial number I write with a pen on the outside of the board. And also it's used to derive things like USB device IDs, so it's useful. Okay, so looks good. Looks good. Okay. So 69 we're skipping for now because that might have a power short. So we'll move on to 70. No. Programmer crashed. That's just mediocre vendor software. It's not an actual issue with the device. Okay, so here's our first failure, I guess you could say. It says we got our serial number, so I'm going to go ahead and paste that in. We're going to mark this as a fail. But what you can see here is it had an error initializing the light sensor. Why? Well, as I noted when I was doing my review, one of those resistors connecting its power rail looked like it wasn't soldered correctly. And I guess it wasn't, which means the light sensor is probably not getting power. So I'm going to mark that one for rework. While I'm at it, I'm going to mark the other one for rework too once I finish testing it. But we'll just go ahead and check all the other functions while we're at it. So the buttons are all working fine. Oh, hey, look. I don't know if you can see, but one of the LEDs isn't working either. Some of the earlier panels, I ran into this a lot. It's very easy to fix, but for some reason, some of the LEDs just didn't seem to solder correctly. So, yeah, I'm just going to take a note. That's D3, so I'll have to fix that. Okay. And last one. Okay, last one. We got our serial number. The microcontroller did initialize, and its light sensor did initialize correctly. This is good. We'll test our buttons. They all look fine, and all the LEDs look good too. So that's going to be a pass. So, there's one last step of this checkout process that I always do. That I might as well do to the boards that I know have no issues, just to get it out of the way. It's a quick USB test. So I connect it to USB, both with a certain bootloader button pressed and without. Make sure that it starts up and registers correctly, and that it outputs over the serial port correctly. So, the way we do this is I should probably have an icon for this. I have this program called USB Tree View. There's something in here that's going to appear and vanish. We just have to look for it, and we'll go through it pretty quickly. So this doesn't take long, so we're going to start with board 66. This time we're actually plugging it into the computer. So the first thing we do is there's this button over here that can be used to fix a completely dead board. It loads a microcontroller into bootloader mode. We plug it in, and then we notice this area, this here showed up, it says STM32 bootloader. We want to see that. It might not always appear green, but it does right now. And then we unplug, plug it back in. Now it says USB serial device. I don't know if this is working. Let's see. Hello? Hello?